Friends, welcome to the program. Now, there was another concept which I was telling you because you have to test the hypothesis. Then one concept was degree of freedom. And I have told you that conceptually, the degree of freedom is in whole number, but mathematically, it can be in fraction. And I will give you the example while I analyze the data. Then next concept was level of significance. Now, you know that you travel by bus. I hope you must be having some experience in traveling by bus. And if there are too many passengers in the bus, then sometime somebody might hit you. And when you tell to that person that why did you hit me, the person may say sorry. That means this event, this act which has taken place, this is when he is saying sorry, that means it is not intentional. It is unintentional, or is it by chance? So that means the event may occur by chance or may not by chance. I'll give another example. Sometime when you go to the market, then you find that you may meet your very old friend. And after coming home, you tell your family members that by chance I met one of my very old friends. The moment you say by chance, this means this meeting was not planned. It was an unplanned one. It is just by chance. The third example, whenever there are exams and when you go to see your result, and you might be thinking that you may fail because you did not do very well in one of the paper. And when you see your result, then sometime you say, oh my God, by chance I have passed. That means this is by chance, means it is due to something, some error. And when it is by chance, not by chance, means it is intentional. Now, many a times, if it rains now, then we say by chance it rains. But during raining season, we never say by chance, because that is the time when you expect rain. But now you do not expect rain because it is not the time of rain. So we say that it is by chance. That means any event may occur by chance and not by chance. So the line which demarcates between the occurrence of event by chance and not by chance. is called level of significance. Now, you know, between the two countries, there is a LOC, line of control. On this side of the line, the land belongs to a particular country. On the other side of the line, the land belongs to another country. Between two districts, again there is a line. So you know that this district, the limit is only up to this. From this onwards, the another district's land starts. So there will always be a line between the two things. And this line, somewhere it is called LOC, somewhere it is called maybe some other one. But in research, we call it a level of significance. So that means that whenever there is something, then we say it is occurrence of event not by chance, and another can be by chance. And when I say not by chance, that means it is intentional. And when I say by chance, that means it is due to error. Now, so this is the line that distinguishes. Now that means whatever you do, any activity, there are chances of error. There is another word, mistake and error. If mistake, you can detect and you can correct it. But error, you do not know the source and therefore you cannot correct it. So this is the major difference between the error and the mistake. I'll give an example. When Chandrayaan-2 was launched, the first launching was discontinued. Why? Because there was a leakage in one of the chambers. So this was a mistake, and therefore they corrected it. Now, second time, when the Chandrayaan-2 was launched, it did not land at the designated point. It landed 6.48 kilometers before. Now, when it did not land at the designated point, this is due to error. And the scientist might have, after analyzing, might have identified the error, the source of the error. Many a times, you know, when the doctor operates on the patient, then it is quite possible that the patient may die on the operation table. And doctor is unable to help the patient. It happens many a times. This is due to error. No doctor can ever say that all my operations were 100% success. There might have been one or two operations which were not a success. And this was not because of mistake. This was because of the error. Let me give another example. When you take your dinner or lunch, you do wash your hands. After washing your hand, if you take it under the microscope, you will still find that your hands are not clean, they are dirty. There are some germs. When you eat, you do wash your plate carefully. And after washing the plate, if you keep it under the microscope, you will again find that the plate is not 100% clean, it is dirty. When you wash your clothes, you try to wash it so nicely, but still you will find that the 100% detergent is not out. Some amount remains. So what is the meaning? The meaning is whatever you do, there are chances of error. Let me give another example from the kitchen. I do not know whether any lady who makes chapati says that not even single time the chapati got burned. I'm sure sometime the chapati might have got burned. It was not intentional act, it was unintentional. Because maybe you were busy and you did not bother and you could not pay attention to the chapati which was on the hot plate. And therefore, or sometime maybe the flame is too high and therefore it may get burned. So these are some of the examples that there are chances of error. Now, so if error has to be there, now in this COVID-19, the vaccine which came up, the Serum Institute of India, do you know what was the efficacy or efficiency of that vaccine? The vaccine which was given by Serum Institute of India, what was the efficacy of that vaccine? Any one of you have any idea? And another vaccine which was from Biotech Hyderabad, what was the efficacy of that vaccine? Any idea? Please write. No idea. Okay. Now, the Serum Institute of India, SII, the vaccine which came up, then they said that if you take the vaccine, then there are chances that 7% of the people may have adverse effect, but 93% of the people will not have adverse effect. So that means the efficacy of this vaccine is 93%. And I hope during pandemic, if you were following the news, then sometime it was given that the vaccine was given and the person died. It's not only in India, even outside India. It happens in UK. It happens other places also. So that means why only 93%? Why not 100%? Because there are always chances of the error. Okay? So now the scientists, researchers have been allowed to have maximum 5% error. Maximum error allowed is 5%. What is the meaning of that? The meaning is, if you conduct a research, if you repeat the same research 100 times, then 95 times you get the same result, but 5 times the result may differ. Now, why 5 times the result will differ? It is because of the error. And this is not intentional, this is unintentional. So that means you can say that 95% we are confident that this result will come, but 5% we are not sure. That is the meaning of the 5% error. And when error is 5%, when error equal to 5%, then you can say that 5 divided by 100, this becomes 0.05. Though 0.05 is called level of significance. So you can have 0.05 as a level of significance, meaning that the error is 5%. And if you repeat the same experiment 100 times, and if you get 99 times the same result, but once, the result may differ. The meaning is that there will be 1% error. Because 99 times you are getting the same result, but once you may not get same result out of 100. So that means there is a 1% error. And 1% error means 1 divided by 100 means 0.01. So 0.01 is the level of significance. Now in social sciences, the maximum allowed error is 5%. In social sciences, the maximum allowed error is 5%. This is the maximum. Minimum, you can have as much as you like. But my dear friend, that there are situations where this condition is not there. I'll give one example. Suppose there is a cancer, a peculiar type of cancer, and there is no medicine available for curing that particular cancer. And suppose one of the pharmaceutical company, they came out with the drug, and if the 100 people take that drug, then 20% will survive. And 80% will not survive. So do you think that drug should be put into the market or not? But remember, there is no drug available. This is the only drug which came up after a lot of experiment. So should this drug be put into the market for use or not? What do you think? Harsha, if we do not put it into the market, even 20% will not survive. Please remember, at least 20% of the people are being cured. Dr. Petro, think about it. Without the medicine, even 20% people are also not surviving. So keep this particular point in the mind. So therefore, it means even if 20% people survive, this medicine, this drug must be available till a better drug comes up. But in the absence of any drug, even this drug is better because the 20% people will survive. Otherwise, all people will die. So this is the point which you have to understand. So that means in pharmacy or in medical science, you cannot stick to the 5%. That if this vaccine, if in this pandemic, the scientists would have stick to the 5%, here the 7% people died. And if they wanted to improve the efficacy so that only 5% of the people will die and rest will survive, then many people would have died. Understand? So therefore, this is a very important point, that every time you cannot say 5% error. So you have to many a times take into consideration the situation, the urgency, and the benefit of the people. But now you have understood the level of significance. Now you have also understood the degree of freedom. Now, how do we use the degree of freedom and level of significance in order to decide whether the value is significant or not? My dear friend, when you take your blood pressure, then what do? Do you compare it with the standard or not? And why do we compare it with the standard? Now, why do we compare it with the standard? We compare it with the standard to take the decision whether the person is having the fever or not, or having the blood pressure or not. Now, in the examination, when the result has to be declared, how do you say that such and such person has got first division and such person has got second division? Do you have some standard there or not? In examination, how do you say that such and such person has passed and such person has failed? So there are also, there are some standards that those who have got the 60% marks or more than that, they are put in the first division. And in some of the universities, if the person has got the 50% marks or more than that, but less than 60%, it is the second division. But in some of the universities, if you have a 48% marks and less than 60% marks, then you are put in second division. Somewhere 50% is the limit and somewhere 48% is the limit. That can happen. So therefore, you have to always compare your reading with the standard reading, your value with the standard value. And if you do not have the standard value, then you will not be able to take decision on the basis of your value. So therefore, in statistics, the statisticians have come up with the standard values that when you are analyzing the data with the help of a t-test, then there is a table which is a standard table for t. Standard table for t value. If you have chi-square, then there is a standard table for the chi-square. If correlation, there is a standard table for the correlation. For every statistical technique, there is a standard value. Like if you have temperature, there is a standard value of temperature. If you have blood pressure, there is a standard value of blood pressure. If you have hemoglobin, there is a standard value of hemoglobin. If you have calcium, there is a standard value of the calcium, and so on and so forth. So that means there are standard values. If these standard values would not have been there, if the standard values would not have been there, then it would have been difficult to say whether someone is having a fever, whether someone is having a high blood pressure, or whether someone is having a low blood pressure. You cannot say. You are able to say because there are standard values. So now, when you analyze your data with the help of the statistical technique, so you will calculate that statistical technique, and then you have to find out whether that statistical value is significant or not. So let me now explain you how will you really find out whether the value is significant or not. Let me give you the rule, and I will share with you the t-value table. Now here, you can see here, it's the table t-test. And you see, here is written one tail, here is written two tail and one tail. So do not bother about one tail or two tail at present. Just see only that here, this is 0.20. If you multiply it by 100, this is 20% error. It is 0.10, it is 10% error. It is 0.05, it is 5% error. 0.02, it is 2% error. And 0.01, it is 1% error. There are tables in some of the books which will give you the level 0.005, 0.001, 0.0005, 0.0001. Like this you can. You will have many tables which is 0.05, 0.0, 0.50, 0.60, 0.70, 0.80. So you can increase the error. Now, you see, this is the degree of freedom. And when degree of freedom is 1, and you can see the values, 3.078, 6.314, and 12.706, and 31.821, and 63.657. Now, if you keep the level of degree of freedom constant, please listen carefully. If you keep the degree of freedom constant and you increase the level of significance, the values increase. Why? Why the table values increase? By increasing the level of significance. Any answer? I'm waiting for your answer. I'm still waiting for your answer. Okay, let me tell you, I'm giving the answer. See, here the error is 20%, here it is 10%, here it is 5%, here it is 2%, here it is 1%. So if the error decreases, suppose you have a 1 liter of milk, and in 1 liter of milk, there must be some water content. Water is the error, because you wanted pure milk, but you are not getting pure milk. The milkman must be mixing some water, so that if he has 10 liter of milk, and if he adds 1 liter of water in it, then he has 11 liter. And if 1 liter is 60 rupees, so he is earning 60 rupees extra. Now, if there is a water in 1 liter, now if you ask the milkman that you do not add water, but you still want to have 1 liter, so in that, will he add pure milk or not? Will the amount of pure milk be increased or not? So when the pure milk is increased, so that means the water content is less. So impurity is less. Now when the impurity is less, the purity increases. So the values are increasing because you are coming quite close to the real value. I'll give another example. When you purchase gold, there is, I do not know whether there is any goldsmith who doesn't mix something in the gold. And if you ask him, okay, please, you do not mix, you mix little. And if you want 1 gram, then in that he has to add pure. So if you remove the impurity, then you have to increase the purity. So therefore, when the error is decreased, then naturally the values will increase. Okay, so this is the reason that with increase in level of significance, the table values increase. Now, listen, that if you keep 0.05 as the level of significance, that means error is 5%. When DF is equal to 1, then the value is 12.706. And when df is equal to 2, now the value suddenly falls and now it is 4.303. Now the question is, keeping the level of significance constant by changing the degree of freedom from 1 to 2, why there is a sudden fall? Have you understood the question? Should I repeat the question or not? Is question clear to you or not? Now, the question is why? Because the error is 5% in 12.76 and here also it is 5%. So error is constant, but then while values decrease. And if you still increase the degree of freedom, now when the df is 2, then the value is 4.033. When df is 3, now the value is 3.182. So the difference between this is decreased. And when it is df is 4, then the value is 2.76. As you keep on increasing the degree of freedom, then the difference between the values keep on decreasing. And after a particular one, you will find that the value that it remains almost the same. Now you can see when df is 23, then the value is 2.069. And when df is 24, then also it is 2.064. The difference is only 0.005. Very little difference. If you see this, again, very little, it is 4.004. If you still say, again 0.04, it is again 0.04, 0.004. It is 0.004. So after a particular degree of freedom, the values almost stabilize, not much difference. Why? Restrictions. What do you mean by restrictions? No, Mamta, think again. Chauhan, think again. My dear friend, let me tell you, in the t-test, the formula I gave you was, the formula for computing degree of freedom in case of t-test is df is equal to n1 plus n2 minus 2. So the formula remains the same. It is always minus 2. So the answer which all of you are giving is not okay. So think again. The question which you have to think, let me write the question and then you may keep on thinking. Keeping df constant, why there is a sudden why there is a sudden decline, in the keeping level of significance constant. Keeping level of significance constant, why there is a sudden decline in the table value as the DF changes from 1 to 2. This is the one question which you should try to answer. What happens when the sample size increases? Joan, when sample size increases, then what happens? Salini, when sample size increases, what happens? Another question is that keeping the level of significance constant, why the decline decreases while the decline decreases as the DF increases. And the third question is keeping the level of significance constant, why after DF equal to you may say DF equal to 23 or 24, no problem. After DF equal to 24, now after DF equal to 24, why the table values stabilize. Now, these are some of the questions which I think you should try to. My dear friend Gaurav, error is the same. Everywhere it is a 5% error. You are not changing the error. Everywhere error is the same. Okay, I hope you have noted down these questions. And then I move ahead and tell you how to use this particular table to find out whether your calculated value is significant or not. Because I have to tell you how to test the hypothesis. So this is important for you to understand. So please note down these and then let us proceed further. Now suppose my DF equal to 28 and my calculated value of t is equal to 1.91. Now, do you think this value has error equal to 5% or more than 5% or less than 5%? DF is equal to 28 and the value at 0.05% is 2.048 and 1% is 2.763. So does it have error more than 5% or less than 5% or equal to 5%? Yes, Shalini, your answer is correct. No, Patra, no, your answer is not all right. Petro, your answer is not all right. Now, it has got error more than 5% because it lies on the left-hand side of 2.048. As you go on the left-hand side, the error is increasing. So that means it has error more than 5%. And if it has error more than 5%, then it is not significant. Now, so that means this value is not significant. Let me give you another example and ask you. Suppose DF is equal to 25. Suppose DF is equal to 25, and the t value is equal to 1.212. Do you think this value has got error less than 5% or more than 5%? In this, the error is more than 5% or less than 5%. So it has more than 5%. So it is not significant. So what is the rule? Now I am giving you the rule. Rule number 1. That for the given DF, are you able to see it clearly or not? For the given DF, if the calculated value is less than the table value given under 0.05 level, then the calculated value is not significant. And whenever the value is not significant, then you need not to mention the level of significance. So you need not to mention the level of significance. You should mention the level of significance only and only if the calculated value is significant. Otherwise, you should not. So I hope the rule number 1 is clear to you. Now suppose if my DF is 29 and my calculated value is 2.045, this is 29 and this is the value at 0.05 and this is the value at 0.01. So do you think that this has error equal to 5% or more than 5% or less than 5%? DF is equal to 29 and T value is equal to 2.045. Then does it have error equal to 5% or more than 5%? Divya, is it less than 5%? Oh my God. This is the value 2.045 and this value is 2.045 and here error is 5%. So it is not less than 5%, it is equal to 5%. So that means it has error equal to 5%. And since it has error equal to 5%, then I'll say it is significant at 0.05 level. Now, if I have the DF is equal to say 60 and my calculated value is 2.50. This is DF is 60. This is the DF 60. And the value given under 0.05 is 2.00. And the value given under 0.01 is 2.660. Then do you think, is it significant at 0.05 level or not? Rawat, it is significant at what level? No, Gaurav. Gaurav, understand the value at 0.0. The value here is 2.66 and this value is 2.50. So it is less than. It is less than the value given under 0.01. So that means it is on the left hand side, but it is more than 2.00. So therefore this value has error less than 5%, has error or has 5% error. So it is significant at 0.05 level. Now what is the rule? The rule is rule number 2. For a given DF, if the calculated value is either equal to or greater than the table value given under 0.05 level, but less than the table value given under 0.01 level, then the calculated value is significant at 0.05 level. See, the value must be equal to the table value given under 0.05 level or more, but it must be less than the value given under 0.01 level. Generally, then it is significant at 0.05 level. I hope it is clear now. Is it clear or not? Now, I'll take another example. Suppose I have the DF is equal to 28 and my T value is equal to 2.763. It is 28 and the value, this is at 0.05 and this is the value at 0.01. What have you to say? What have you to say about this value? That T is equal to 2.763. Is it significant? If yes, at what level? Oh, Divya. Okay, less than 5%. All right. So therefore, it has error. It has error equal to 1%. So therefore, it is significant at 0.01 level. Now, if your DF is equal to 30 and your T value is equal to, let us say, 4.56. So this is 30. And the value under 0.05 is this. And the value under 0.01 is this. So what have you to say? Is it significant? If yes, at what level? Yes. So it has error. It has 1% error because we will consider it 1. So it is significant at 0.1. So the third rule is that for the given DF, if the calculated value is either equal to or more than the table value given under 0.01 level, then the calculated value is significant at 0.01 level. Have you understood all the three rules or not? The rule number 1, rule number 2, and rule number 3. Now I'm asking you one question. The question I'm asking is, suppose your DF is equal to 40 and your T value is equal to 6.10. So this is 40. This is 40. And this is the value under 0.05. And this is the value under 0.01. Now, can I say that it is significant both at 0.05 level as well as 0.01 level? Is this sentence correct or incorrect? Is this sentence is correct or wrong? No, my dear friend, this particular sentence that it is significant both at 0.01 level and 0.0, this is not correct. It is wrong. So this sentence is wrong. This sentence is wrong. Why? Because if the value is significant at a higher level, then it has to be significant at a lower level. So because the value is already significant at 0.01 level, that means it has to be significant at a lower level where error is more. Now, when I'm saying error is less, say if you have got 90% marks, then I should not say that you have got more than 95, 96, 97, 98, 99. Because you have got 90% marks, that means you have got more than 78, 79, 80, 81. It is automatically understood. If your weight is 45 kg, I should not say that your weight is more than 42 kg, 43 kg, 44 kg. No. Once I say 45, it means it is more than 44. So if the value is significant at a higher level, then you should not write that it is significant both at 0.05 and 0.01 level. You should write the highest level, and highest is 0.01. I don't know whether you have understood or not. Now, if you have a value something like this, if df is equal to 40 and you have value 2.021, then can I say like this, it is significant at 0.05 level, but not at 0.01 level. Is this sentence correct or wrong? Please see, I have written it is significant at 0.05 level, but not at 0.01 level. If a value is significant at a lower level, then it is automatically understood that it is not significant at a higher level. Because if the value is significant at a higher level, then you will mention the higher level. But if the value is significant at a lower level, then you will not mention the higher level. So this sentence is wrong. So this sentence is wrong. You should say that it is significant at 0.05 level. That's all. Because the moment you say it is significant at 0.05 level, it is understood that it is not significant at 0.01 level. Now, these are some of the mistakes which many of the people they do. So you have to be very, very careful. So I hope you have understood the rule. Now let me take one title and I will write one objective. I will write the hypothesis. Then I will take the data and I will test the hypothesis and will say this is what is called testing of a hypothesis. So you cannot test the hypothesis until and unless you do not collect your data. So let me write one object title and objective and hypothesis. Suppose I am writing a title like this. A study of stress of teachers working in private colleges of Kanpur. Objective is to compare mean scores of stress of male and female teachers. And my hypothesis is that there is no significant difference in mean scores of stress of male and female teachers. And this is my hypothesis. So let me go to my SPSS. No, Bahadur, not tomorrow, beta. Why? Do you have some work, Bahadur? Bahadur Singh, do you have some work? Then tomorrow also I will tell, but start understanding today. So now, dear friends, let us have the SPSS. I have the SPSS. This is the SPSS. I'm sure you might have seen the SPSS. Here is a VAR mixed variable. In what particular column you have to enter the information of one variable. And I have already told you that you have continuous variable and you have discrete variable. Now, in this particular objective, can you name the variables? From this objective, can you name the variables? Yes. Yes, Shalini, your answer is correct. Patnaik, your answer is correct. Pramod, your answer is not correct. My dear friend, here I have one variable is stress. And another variable is a gender. Because I have male and female. So gender is a discontinuous variable and stress is a continuous variable. So you have the two variables. So let us go to SPSS. Now, I have to first go to the variable view. This is the variable view. Now, which variable name do you want to write first? It is gender or stress? Which variable name do you want to write first? One person has said stress, another has said gender. So two people have said gender, two people have said stress. Now three people have said gender. Okay, let us put gender here. Now gender has got how many levels? Only 2 levels. And here is a value. Now here I say the one means male teachers. I will add. Then 2 means female teachers. I will add. So this is how you have to define the discontinuous variable. And now another is a continuous, that is stress. And you enter. So you have to first go to the variable view. And if you have two variables, then you have the two columns. You will use only two columns. You can see the two columns here. The first column is gender, another column is stress. If you have got four variables, then you need four columns. If you have 20 variables, you need 20 columns. So this should be very, very clear to you. Now I can enter the gender of the first person is say female, that is 2. And the stress I'm taking the score between 10 and 30. So I'll say 20. Then the second person is male, and suppose his score is 90. Another person is male, then his score is, let's say 21. So I can keep on entering the data like this, or I can first enter the data of the gender and then the data of the stress. So let me enter the data of the gender. The number may be equal or unequal, it does not matter. Now I am entering the suppose I have entered the data. Bahadur, the gender has got two levels. So it is discontinuous. Bahadur, I did tell you the definition of a continuous variable. Continuous variable is one which can be expressed both in whole number as well as in fraction. And discontinuous variable is one which can be only expressed in whole number. See, gender is 1 and 2. You cannot have 1.5. Now, Rafi, it does not matter. You can have 25, no problem at all. Forget about 30. You can still have this, no problem at all. Now, after entering, I go to analyze. You can see analyze here. Now, can you, according to the objective, I have to compare mean. Can you find out somewhere compare mean? Here is a compare mean. As soon as you bring the cursor in the compare mean, here you get the independent samples t-test. I told you that another name of the t-test is independent samples t-test. So you click it here. Now this is the test variable. The test variable is the variable which is a continuous variable. And here the continuous variable is a stress. So I shift it here. This is the grouping variable. Grouping variable is the discontinuous variable, and that is gender. So I shift gender here. The moment I shift gender, these are two question marks. So we click on define groups, and I have already defined as 1 and 2. So you say continue and you say continue. Now you have got your males are 14 and females are 11. The mean stress of male is 19.92 and female is 19.45. And this is the standard deviation of the male and this is the standard deviation of the female. Now this is the t value. And in this t value, the error is 0.286 multiplied by 100, 28.6% error. So is this value significant or not? Bahadur, there is a tool. It is a stress scale. And suppose I have administered the stress scale and I have analyzed. Hello. नहीं, मैं अभी जरा वेबिनार में हूँ, मैं बात करता हूँ जैसे खत्म कर दूँ. So you have a tool. I administer the tool and then I got the score. So that makes this t value, which is 1.093, it has 28.6% error. So it makes it is not significant. Now you can see here, this is the F value. And here it is 11's test for equality of variances. And this F value has got 17% error. What is the meaning? The meaning is whatever are the differences in the male, the same differences are in the female. So that means equal variances condition is satisfied. And equal variances condition, if it is not satisfied, then you see this is your t value and this is your degree of freedom. And if which is in fraction, 22.991. So at present, we will take the upper value of the t, because equal variances assumed condition is satisfied. So that means I have the values like this now. And I will use these values to test my hypothesis. And then I will take another example tomorrow and will tell you how to test the hypothesis. So let me write this first. The male is 19.928, I can say 19.93, and female is 19.45. And standard deviation is 1.19 for the male and 0.91 for the female. And there are 14 and the t value is 1.09. So let me use these values, and please never copy and paste, because there are many values which you do not require. So you note down the values. So now this is my objective. And I have to write the caption heading here. And caption heading is gender-wise comparison of mean scores of gender-wise comparison of mean scores of stress of teachers. This should be the heading. And now here is the objective Y was the first objective was to compare mean scores of stress of male and female teachers. The data were analyzed with the help of t-test and the results are given in table. Now, if you are writing a paper, then this will be table number 1. But if you are writing a thesis, then this will be in chapter number 4, then you should have 4.1. So that you have to tell, will you want me to write 4.1 or 1? Which one do you want? All right. If it is 4.1, then I write this 4.2.0. Now here I'll put the table. I'm inserting the table. Now here I say gender, then I say mean, then I say SD, then I say N, and then I say T value. Here it is male, then female. The male mean is 19.93. The female is 19.45. SD is 1.19 and this is 0.91. N is 14 and 11. And T value is 1.09. So here it will be gender-wise mean, SD, N, and T values of stress of teacher. Now, I have written values means mean value, SD value, N value, and T value. And now I have to write like this from table 4.1, it can be seen that the T value is 1.09, which is not significant. Now, when it is not significant, you need not to mention the level of significance. it is automatically understood that the error is more than 5%. Now, when the t value is not significant, the meaning is it indicates that there is no significant difference in mean scores. There's no significant difference in mean scores of stress of male and female teachers. Because t value is not significant, that means whatever is the mean score of stress of male and the female also the same, so they do not differ significantly. Thus, the null hypothesis that there is no significant difference in mean scores of stress of male and female teachers is, what should I say? Is rejected or is not rejected or is accepted? What should I write? No, Patnaik, we cannot write accepted. Accepted is a very, very strong word, and you can use the word accepted only and only if you collect the data from all members of the population. And in research, we never collect the data from all members of the population. We only collect the data from the sample. And there
Dear friends, actually sir is facing light tripping problem. So please wait. Please wait some time. He will be joining again. He will be join again. Please wait.
was a power failure, so that is why it got disconnected. So therefore, in is not rejected. Now, the moment you say is not rejected or is rejected, your hypothesis has been tested. So this is what is called testing of a hypothesis. And now I can say it may be said that both male and female teachers were found to have stress to the same level. And this becomes your finding. So if you move very systematically, then it is not very difficult to get the finding. So this is what is called testing of a hypothesis. Tomorrow, I will take another example where your value is significant, and then how do we go about? I will tell you that. So any question, any participant like to ask, otherwise I'm closing it. Any participant like to ask any question? You have been unmuted, then you can ask me the question. And if there is no question, then thank you very much. See you tomorrow.
Thank you, sir. Many thanks to you, sir. And many.
Whether it is survey research or experimental research, it does not matter. The name is t-test, or it is also called independent samples t-test. It is not sample t-test. It has got two names, t-test or independent samples t-test. It does not matter whether you have data from experimental or you have data from survey research. It must be quantitative data, and only for two independent groups. All right. So thank you very much. Keep learning, stay safe, and see you.
Thank you, sir. Many thanks to you, and many thanks to all.